Hi, this is Asing. You are now watching Asing Math TV.
Normal distribution is a probability distribution that characterizes the behavior of a continuous random variable. It is recognized by its bell-shaped curve, which exhibits symmetry around its mean value. Consider, the weight of an apple follows a normal distribution with a mean of 85 grams and a standard deviation of 10 grams. If we denote x as the weight of an apple, we can describe x as following a normal distribution with two important parameters, mu, that is mean equal to 85, and sigma squared, that is variance equal to 10 squared. If we are given the probability that the weight of an apple is greater than 97.8 grams is 0.1003, then we can express this mathematically as the probability of x being greater than 97.8 is equal to 0.1003. To determine this probability, we can utilize a calculator or the standard normal distribution table. But, in this video, we'll only be concentrating on the standard normal distribution table. Before consulting the table, it's essential to standardize the value by subtracting the mean and dividing by the standard deviation. The standardized value is known as the Z-score, which facilitates the probability calculation. Before proceeding, let's clarify something. The numbers 1.28 and 0.1003 totally convey two different meanings. Specifically, 1.28 represents a Z-score, that is a point situated along the red line. In general, Z-scores range from negative infinity to positive infinity. Conversely, 0.1003 denotes the probability associated with the corresponding Z-score. It signifies the area under the curve bounded by the Z-score. The shading direction depends on the symbol's context. In general, probabilities range from a minimum of 0 to a maximum of 1. Recall that normal distribution is symmetric around the mean value. Equally dividing the distribution yields equal areas on both sides, with each side accounting for 0.5 of the total probability, which is 1. However, any non-zero Z-score partitions the distribution unequally, with one side having more than half the probability and the other side having less. Returning to the task at hand, to derive the probability from the standard normal distribution table using 1.28, extract the first two digits and get it from this column while the last digit from this row. Note that the table provides values up to 2 decimal places. For values beyond that, the easiest approach is to round the Z-score appropriately. However, for a higher level of accuracy, we are strongly encouraged to determine the value using the interpolation method. Consider this bell-shaped curve. The value 1.28, a positive number, represents a point located on the right side of the curve. Let's mark it here. On the other hand, the direction of shading depends on the symbol, and for this case, we should shade the area to the right. From the table, 1.28 corresponds to 0.8997. Since this number is more than 0.5, thus it refers to the left side's area, not the right. However, since the total probability is 1, the right side's area is found by subtracting 0.8997 from 1. Now, what if we're asked to find the probability for a given negative Z-score? Even though the table doesn't display negative Z-scores, we can rely on normal distribution symmetry. This symmetry assures that the probability of the left side is the same as that of the right. Utilizing this principle, we can confidently arrive at the correct answer. That concludes this video. If you're seeking more examples, feel free to explore the link provided in the video's description. Thanks for watching, and have a wonderful day.